So, hello everyone. Today we'll be starting the mechanics. Yes, of course, we have started mechanics when we have started the vector, but now we have started the mechanics. So, mechanics is the branch of physics that deals with the conditions of rest or motion of the material objects around us. Okay, and mechanics has its three subparts: statistics, kinematics, and dynamics. What is statics? It is the branch of mechanics that deals with the study of objects at rest or in equilibrium, even when they are under the action of several forces. Kinematics, it is the branch of mechanics that deals with the study of motion of objects without considering the cause of motion. In kinematics, we will only be seeing why or how the motion is happening. Like the motion is happening, but we won't see how or like why. We won't be considering the cause. Here, the cause of motion we won't be considering, but in dynamics, let's see what is in dynamics. It is the branch of mechanics that deals with the study of motion of objects taking into consideration the cause of their motion. So here we will be taking the cause, okay? But when it's kinematics, then we won't be seeing the cause, okay? Now comes rest and motion. Rest. An object is said to be at rest if it does not change its position with respect to its surrounding with the passage of time. A book lying on a table. The book is lying on the table, it is at rest. Okay? It is not moving with its surrounding. When it's motion, an object is said to be in motion if it changes its position with respect to its surrounding with the passage of time. Example, a train moving on its tracks on the rails. Now the train is moving here. Okay, now if I take this as a surrounding, if I and you are sitting here, then if I would ask you that am I moving, then in respect to this train, the things inside the train, you'll say that no, we both are at rest. But when I ask a person outside here that tell me am I in motion, then he'll say that yes, I'm in motion. But when I'll ask you that are we in motion, you'll say we are at rest. So a body is moving or a body is at rest, we can say this in comparing, in taking respect to the surrounding, to the things around us. Okay, now comes the concept of a point object. What is meant by a point object? Give suitable examples. Point object, if the position of an object changes by distances much greater than its own size in a reasonable duration of time, then the object may be regarded as a point object. Now if I say that this is me, okay, and this is an ant. Now if this would move here and there in me, now this is a point object, okay, because the size of the ant is really very much less than me. Okay, so the ant is a point object if it is moving in me. Okay, we can even say earth can be regarded as a point object for studying its motion and around the sun. A train under a journey of several hundred kilometers can be regarded as a point object. Okay, now we come to the point motion in one dimension. The motion where there is only one axis, like I'm walking on the road. Okay, I'm walking on the road, it's simple. I'm not jumping, I'm just walking, so I'm only moving in one axis. So here this means motion in one dimension, where we have motion happening only in one axis. Motion in two dimension, when I throw a ball, then you will be seeing it covers both x and y. Yes, so here we can say that there is an involvement of two axes. Okay, this is motion in three dimension. Now motion, it was motion in two dimension, now it is motion in three dimension. Here we have three dimension, three axes. Okay, now here the y and x and z is 0. Okay, and here the z axis is 0, the coordinates, and here there's an involvement of three axes, like I'm flying a kite, then there is a motion of three dimension, or a aeroplane, or an aeroplane in space. Okay, so he'll have three axes, x2, x1, y, all the three axes involvements are there. Now comes distance. Now what is distance? Distance is the path length. It is the length of actual path traversed by a body between its initial and final positions. Distance is a scalar quantity. So here we will only have magnitude. It is the length. It is the length covered. Okay. Now the dimension of distance is m0, l1 and t0. Now please be careful with the SI and CGS units. Okay, in the question there are sometimes, or everything is given in the SI units and something are given in CGS unit, and you forgot to convert it in the mean, in like everything is in SI unit and one thing is given in CGS unit, and you need to convert it into SI unit. So please be careful when it is the SI and CGS units in the question. Okay. Now, distance can be 0 or positive. Okay, but why it cannot? It can never be negative. Okay, because distance is a scalar quantity. Okay, we can never get distance as negative because there is no involvement of direction. Direction indicates the positive and negative values. Okay, it has no direction, so of course the distance can never be negative. If I took this direction as positive and this direction as negative, then we can say that okay, the value we will add up, either it is positive or negative, but when it's distance, then there is no involvement of direction because it's a scalar quantity. Now, displacement. Displacement is a vector quantity. Displacement is the shortest length between the initial and final positions, and the most important thing is it should be in a fixed direction. The direction should not be changed. If direction is changed, displacement changes. Okay, it's a vector quantity, so here the direction, the involvement of direction is there. Now the dimension of displacement is m0, l1 and t0. Now please be careful with the SI units and CGS units. The SI unit is meter and CGS unit is centimeter. Now displacement can be negative, 0 or positive, because here the involvement of direction is there. Okay, if we take this as positive and this as negative, then we can say that when we'll take out the displacement, then we'll be putting the values, either it is in minus or in plus directions. Okay, now let's take an example. If I need to go to my school, okay, then I'm covering this path and I'm going to my school. Okay, this path is of 3 kilometers, and when I'm returning home, I take this path and I came home. Okay, this is 4 kilometers. Okay, now if I'll ask you what is the distance you covered while you went to your school and you returned to your home, then we can easily say yes, it will be 7 kilometers. Okay, but when we'll say that what is the displacement, we'll say that when I'm talking about going to school and coming back to home, then initial and final positions are same, so displacement will be 0. But if I say that going home to school, what is the displacement? If I'll take this path, then we'll see that our direction is changing. Okay, we can see our direction is changing, so here we can't take our displacement. Same goes to here. If I say that okay, while returning, what will happen? The direction is changing, so we need to take the shortest distance. The shortest distance between my point and this is the path. Okay, this will be the path, so this is my displacement, where I will see that here we have a fixed direction. Okay, we have a fixed direction. Now if this is my initial and this is my final position, and this is 1 kilometer, so Of course, displacement is the shortest distance. So in many of the cases, in I think in every of the cases, the displacement will be less than distance. Displacement will never be more than distance. It can be equal to the distance, but displacement will always be less than distance. Okay, and if I say that I will give both my initial and final positions in my home, then the displacement is 0. Okay, now comes speed. Speed is a scalar quantity. Again, here we'll have only and only magnitude. Now speed can be 0 or positive, but it can never be negative because it has no direction. Okay, the dimension of speed is m0 l1 t minus 1, and here we have SI unit meter per second and centimeter per second. Please be very careful with the SI and CGS units. Okay, now speed is the distance covered by time, meter per second. Okay, now if I'll say, have you ever heard that he is saying that if I kept a block, then we will say that it is moving with 2 meter per second. We don't have a direction in speed, we only have a magnitude. When we talk about speed, we only have a magnitude, there is no direction. Okay, now the types of speed are uniform speed, variable speed, average speed, and instantaneous speed. Okay, now in uniform speed we'll have equal distances in equal time intervals. The body will cover equal distance in equal time intervals. When it's variable speed, he will cover unequal distances in equal time intervals or unequal distances in unequal time intervals. Okay, when it's average speed, we see that the total distance by total time taken is the average speed. So uniform speed is what? Equal distance covered in equal time. Variable speed is unequal distance covered in equal time or unequal distance covered in unequal time intervals. Okay, now comes instantaneous speed. Instantaneous speed is the speed at an instant. Like you are driving a car and I'm saying you that this instant tell me your speed, the speed which you are traveling. Then you'll say that okay, this is the speed, like 28 kilometer per second per hour. Okay, how is instantaneous speed calculated? It is calculated by dx by dt. This is the complete x. Okay, a very small is called, the small part of x is called dx, and the time taken is dt. Okay, now comes velocity. Velocity is a vector quantity. When it's a vector quantity, we will have both magnitude and direction. Okay, and the dimension of velocity is m0 l1 t minus 1. And again, please be careful with the SI and CGS units. It's meter per second and centimeter per second. Now in velocity can be negative, positive, or 0. Why? Because we have an involvement of direction. Okay, this is positive, this is negative. We can also have velocity sometimes 0, like I'm moving in a circle. I'll explain this. So velocity is displacement by time. Now the types of velocity. This is the uniform velocity, where we have equal displacements covered in equal time intervals. Okay, when it's a variable velocity, then we have unequal displacement covered in equal time intervals or in unequal time intervals. And average velocity is the total displacement by total time taken. Instantaneous velocity is again the same, at an instant. Okay, at an instant, like a very small we'll be taking. So dv is equal to dx by dt. Okay, now we take an example of a circle where we'll be saying that here speed can be constant. Okay, but velocity can't be constant. Velocity cannot be constant. but the magnitude of velocity can be constant. Okay, because here we'll see that at every point the direction is changing. Okay, you can see the direction is changing, so we can say that yes, the magnitude of velocity is constant, but the direction is not fixed. So velocity is not constant when it's a circle. Okay, but speed is constant. Now if I'll ask what is the distance you covered, then the distance you'll simply write I covered the perimeter 2 pi r. What is the displacement you covered? Displacement, if I started from here and I ended up here, then the displacement is 0. But if I started here, I moved till here to here, and this is my initial and this is my final position, so this distance is displacement, not this. Okay, this is distance. Clear? Now comes equal, uniform and non-uniform motion. Non-uniform motion. Okay, first we should do it. Uniform motion. Now uniform motion, equal distance or displacement traveled in equal time intervals with a same or equal same velocity or speed. In uniform velocity, all will be equal or will be same, and in non-uniform velocity, one is unequal or the all are unequal. Unequal distance in equal time intervals, unequal displacement in unequal velocities in unequal time intervals. Okay, so this is uniform and this is non-uniform motions. Now comes acceleration. Acceleration is change in velocity by time. Okay, it's a vector quantity, so of course we'll have direction, then we will have acceleration and the negative acceleration too, which is called retardation. Okay, the SI units is meter per second square, and CGS is centimeter per second square. Okay, and the dimension is m0, l1 and t minus 2. Now variable velocity, when the velocity is variable, then there is a change in velocity. Okay, so where we have a change in velocity, acceleration begins. Okay, and when the velocity is constant, acceleration is 0, because there is no change in velocity, so acceleration will be 0. Now comes the types of acceleration. Now the types of acceleration is uniform acceleration, where we will have equal amount of change in velocity in equal time interval. Okay, in uniform acceleration we have equal amount of change in velocity in equal time, and in variable acceleration we have unequal change in velocity in equal interval of time or in unequal interval of time. So here there is unequal change in velocity, here is equal amount of change in velocity. The average acceleration is v2 minus v1 by t2 minus t1. It's velocity by time, meter per second square. Now comes instantaneous acceleration at a specific instant. Acceleration is dv by dt. Now we know dv is dx by dt. So we come to here d square x by dt square. Look, dv equal to dx by dt. So here we wrote dA equal to dv. This is dv. So d square x by dt square. Now we have some important equations of motion which we'll be needing in the kinematics part. Wherever in mechanics question we have kinematics, we'll be needing either of these three equations. Sometimes we can need this too, where we have a series given like 1 2 and it's till n. Here we need this. So the first one is v equal to u plus at, s equals to ut plus half at square, v square equals to u square plus 2as, and the SNH term is u plus a by 2 2n minus 2. V is velocity, u is initial velocity, this is final velocity, this is initial velocity, this is acceleration, this is the time taken. S is displacement, Okay, this is initial velocity, this is time interval, this is acceleration, this is time interval. Final velocity, initial velocity, acceleration, and displacement. This is the displacement taking up. Now I'll be showing the derivations if I think it's really very much required, and in the next video we'll be covering up the graphs which is there in kinematics. Okay, so thanks for watching.